Hello, welcome to another Mr. Wise video. This time, today we're talking about astronomical distances. So we use distance measurements every day. There's different units of measurement are appropriate for different distances. You know, it says here, for example, a millimeter works fine to measure rainfall on an average day, but you, of course, would not use a millimeter to measure the depth of the ocean. Same thing with, like, you want to calculate the mass of an elephant or something, or a building, you're not going to use grams. You're probably going to use kilograms, maybe tons, something like that. So we need to figure out some units that are appropriate for space. So the first one is an astronomical unit. Now, an astronomical unit is the distance from the Earth to the Sun. Is the distance from the Earth to the Sun. Now, we know that the distance between the Earth and the Sun isn't always constant. There's an aphelion and a periphelion, but this is the average distance. Now, this is equal to 150 million kilometers. Sorry, I think too many ends. 150 million kilometers. We could also write this out if we wanted to, as in scientific notation form, as 1.5 times 10 to the power. That's what that symbol means. Kilometers. 1.5 times 10 to the power of 8 kilometers. So that's the first one we're talking about, astronomical unit. The next one, which you've probably heard of before, it's the one most used to describe distances in space, is a light year. Now, a light year is exactly what it says. A light year is the distance light will travel in 1 year. So the distance light travels in 1 year. So this is equal to 9.5 trillion kilometers, which, if we want to write it out, can be written out as 9.46, I guess is the more precise, times 10 to the power of 12 kilometers. So when it's traveling and it's uninhibited, it will travel 9.5 trillion kilometers in 1 year, which is what you're going to hear mostly about. It's the one to keep in mind. So we're just going to go through this chart and work through it. So the first unit of measurement, as we're getting from bigger, or from smaller to bigger, the first thing you would think of is centimeters. So you are likely about 150 centimeters. Some might be taller, some might be shorter. I'm somewhere around 200, I'm not totally sure. But that's the easiest one, the smallest. So next thing is meters. So a thing you could place would be like your room or something. We know that in a meter, there's of course 100 centimeters. So a room might be 10 meters by 12 meters. The next big thing you can think of is like a city. So the city of Winnipeg is 40 kilometers in diameter. Now, of course, a kilometer, because the prefix is kilo, and kilo means 1,000. So there is 1,000 meters in 1 kilometer, the prefix kilo. The next thing you can think of is Canada. Canada is about 7,250 kilometers from coast to coast. And then the next thing you can think of is the Earth, when you think of next getting bigger. So we're still going to use kilometers here, but it's a fairly large number when we think about it. Sorry, actually right here. So Earth's diameter is about 12,700 kilometers. So a fairly large number. Again, if you want to write that out, you can quickly put it to 1.27 times 10 to the move 4 times 4 kilometers, if you wanted to. So then when we get to the solar system, you could still use kilometers, but we decided to make the term astronomical unit. So 1 sorry. This is bad. Am I right there? Yeah, okay. Astronomical unit. So one astronomical unit is, as we saw earlier, equal to 150 million. Sorry, I not supposed to be meter there. I should add a K there. Sure, why not? 150 million kilometers. So 1 AU. Can write it here if we want. This is what equal to 1 AU is equal to that. So Neptune is 30 AUs from the sun. So in other words, you could think of it as Neptune is 30 times farther away from the sun than the Earth is. The next thing, so we're going to describe how big the Milky Way galaxy is. So we're not going to use astronomical units for that. We're going to use light years. So a light year. So 1 light year is equal to 63,000 astronomical units, so fairly large number. The Milky Way itself, the Milky Way galaxy is of course the galaxy we reside in, is about 120,000 light years across. And then once you get to this Milky Way galaxy, the next biggest step is universe. There's other stuff in there, clusters and superclusters, but we're not worried about that. So galaxy, we're going to go to universe. So the universe is lots of light years across. So the visible universe is actually a pretty staggering number, 93 billion light years. Of the visible universe, we know is 93 billion light years across. So fairly large number. So here I have one of the problems you're given, and so I'm just going to do this first problem here with you to make it easier. So essentially, so given that light travels at 300 million meters per second, which of course m divided by s, calculate how far light could travel in 1 year. So in other words, how many? So I shouldn't say in other words. So first thing you need to think about. So we have seconds, and then we have year. So we're going to need to convert this somehow, seconds to year. So we need to think about how many seconds are in a year. So first we're just going to start off with is the first number here. So 300 million. So that's 300 million meters, which is of course divided by your seconds. So your seconds. So to get that, to serve how far it travels in a year, we're going to think we need to convert it to a year, these seconds. So of course what we're going to first do is how many seconds are in a minute. Well, there's 60 seconds, so we're going to go 60 seconds in 1 minute. How many minutes are in an hour? Well, of course there are 60 min per hour. How many hours are in a day? Of course there are 24. 24 hours in 1 day. And then, of course, how many days are in a year? 365. 365 in 1 year. So we're going to add it all up, and we get the number 9.46 times 10 to the 15 meters per year. So that's how given how far light could travel in 1 year. So we can also convert this if we want to kilometers, which is simply 9.46 times 10 to the 12th kilometers per year, which is the same distance, the distance light travels in 1 year. That's exactly what it is. Simple problem. Thank you.